Now that we have discussed about linear polynomial, let's enter into discussing about a linear equation in the same two variables x and y. Linear equation in two variables x and y. Definition. So as we come across, let's recap with the linear polynomial, which is defined to be a polynomial p of x comma y is said to be a linear polynomial in two variables x and y if this is equal to ax plus by plus c, provided all the constants a, b, c belong to R and a not equal to 0 and b not equal to 0. Is how we define a polynomial with a, b, c belonging to real numbers and a not equal to 0 and b not equal to 0. So let's see how we can define the linear equation derived from the linear polynomial. So this polynomial p of x comma y equals ax plus by plus c is called a linear polynomial in two variables x and y if a, b, c belong to R and a not equal to 0, b not equal to 0. Now what is an equation? When does a polynomial become an equation? Is the biggest question in comparison. So as we see here, the linear equation is obtained when I equate the given polynomial to 0. So when I want to convert this into an equation, I just take this in the form equal to 0. That implies a linear equation in x and y is defined to be p of x comma y equal to 0, which is indirectly ax plus by plus c equal to 0. Therefore, a linear equation in x and y is finally concluded to be ax plus by plus c equal to 0 with a, b, c belonging to real numbers, as with the same condition as that for the linear polynomial. So a, b, c must belong to real number, and the second condition being that a and b should be non-zero real numbers and a not equal to 0 and b is also not equal to 0 is how I define the linear equation in two variables x and y. Linear equation in two variables x and y. Ax plus by plus c equal to 0. A, b, c belong to R and a not equal to 0, b not equal to 0 is how I define. For example, I take an equation in the form 2x plus 5y minus 3 equal to 0, then let's test whether this is a linear equation in two variables x and y. So initially I test with rule 1. The rule 1 is first to take with the given equation in the form equal to 0. Rule 1 is the degree is 1 and rule 2 is the degree is 1 because its power is 1 for each x and y. So first term the degree is 1, for second term the degree is 1, and for the third term the degree is 0. So the highest degree out here is 1. Therefore, that is the rule 1 through which we identify it is highest degree in 1. And number of variables in this polynomial is x and y. Therefore, I have two variables being x and y. Therefore, the number of variables is 2, is the rule 2 which I identify in the given problem. The rule 3 is that the left hand side of the polynomial is equated or can be equated to 0. So left hand side is equated to 0. Therefore, on these three conditions, I can say that the given problem is a linear equation in two variables x and y. If I have these three conditions satisfied, therefore, the given equation (2x plus 5y minus 3 equal to 0) is a linear equation in two variables x and y, is how I understand the given example problem. Any problem given out there to be identified for linear equation in the number of variables, we first take the rule 1 in deciding the highest degree of each of the terms. Finding the degree of each term, we extract the highest degree. If the highest degree of the entire given expression is equal to 1, then it is linear. And here the highest degree is 1. Therefore, this given expression is a linear polynomial. Next is about finding the number of variables in the polynomial. Clearly, we identify the number of variables in the entire polynomial. The variables here being x and y. Therefore, the number of variables is 2, x and y. Therefore, I can now assume that this is a linear polynomial in two variables x and y, is how we justify. Thirdly, about identifying for the equation. Imagine that if I can write the expression in the form equal to 0, then I can say that the given expression being expressed as equal to 0 makes me clearly confirm that the given equation is a linear polynomial, a linear equation in two variables x and y. A polynomial converts to an equation if it is equated to 0. Therefore, the given equation 2x plus 5y minus 3 equal to 0 is a linear equation in two variables x and y, is how I conclude the given example problem. Now let's take an example problem where the given expression is not equated to 0 and justify if that is a linear equation in two variables x and y. So let's take an example problem to understand the concept more stronger. For example, I have an equation which says 2x minus 5y plus 4 equals 3 minus 9x plus 2y. Now this expression clearly makes me witness that this is not equal to 0. So do I call this a linear equation or do I call this an equation? Let's see how we can justify. Before we do this example problem, one thing is for sure, that we need to justify only after the complete solving. Bring it to the most simplified form and then justify for a linear equation in two variables x and y. So let's take this example problem, investigate it. The given problem is 2x minus 5y plus 4 equals 3 minus 9x plus 2y is what is the given expression. So let me try to simplify this by taking all the terms to the left. As I can see that this can be further simplified by taking each of the terms on the right hand side to the left hand side. So 2x minus 5y plus 4 plus 3, when I bring it to the left, it is minus 3, minus 9x when brought to the left is 9x plus 2y to the left is minus 2y equals 0. So I have all the terms on the right which are brought to the left, equating to 0. Linear equation is always equated to 0. Now let's simplify, where my 2x and 9x are added to give 11x. and minus 5y and minus 2y are added to give minus 7y, because minus 5 minus 2 is minus 7. Then the constants here are added to get 4 minus 3, which is 1, equal to 0. So this is now the most simplified equation of the given problem. So let's see if this is a linear equation in two variables x and y, to be followed with the three rules. Rule 1, the degree of first term is 1, the degree of the second term is also 1, the degree of this is 0, therefore my rule 1 is highest degree out of all these is 1, therefore it's linear. Next, the rule 2, identifying the number of variables. I clearly see that there are two variables x and y. So I have two variables x and y, and it is a linear, and as I see that the left hand side is equal to 0, that's the rule 3, my LHS is equal to 0, therefore it's an equation. And overall I conclude that this is a linear equation in two variables x and y. Indirectly, the given problem, though is not expressed with 0 on the right hand side, needs to be more simplified until it reaches to the complete simplified form and then equated to 0, and thus justifying for the given example problem to be a linear or not a linear equation. This example problem, 2x minus 5y plus 4 equal to 3 minus 9x plus 2y, is a linear equation in two variables x and y. Its simplified form, its most simplified form being 11x minus 7y plus 1 equal to 0. Linear equation in two variables x and y.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.